propranolol, esmonolol, atenolol. We already seen in case of antihypertensive drugs. Clear? And next one is class 3. Class 3 you are having potassium channel blockers. Examples are potassium channel blockers. Examples will be your amiodarone and sotalol. And class 4 you are having calcium channel blockers. Okay? Calcium channel blockers. So in case of your antiarrhythmic drugs, you will be using non-dihydropyridine calcium channel blockers. Here, calcium channel blockers will be having two types. One is dihydropyridines and second one is non-dihydropyridines. Generally, dihydropyridines will be using in the antihypertensive and will be using as antihypertensive agents and anti-anginal drugs. Examples will be your nifedipine, felodipine, amlodipine. So these are the dihydropyridines. In case of arrhythmia, you will be using non-dihydropyridines. So again, they are divided into different types based on their chemical structure. Okay. First one is diphenyl alkylamide. Example is your verapamil. Okay. And next one is benzothiazepine derivative. That is nothing but diltiazem. Okay. And third classification is aminopropanol ethers. Okay. Example will be piperidine. This is the classification of your antiarrhythmic drugs. Sulfate. So pyridine sulfate. So this is the drug which is obtained from the natural product, which is nothing but bark of your cinchona alkaloids. Okay, Cinchona officinalis. Cinchona officinalis is the name for the plant. Will be obtained from the bark. Okay, these are called as quinoline alkaloids. Okay, so I already you know pyridine sulfate is nothing but it is obtained from the quinoline alkaloid. Basic ring will be quinoline nucleus. What is quinoline nucleus? A benzene ring which is fused with the pyridine. Okay, benzene fused with pyridine is called as your quinoline. Okay, this is the basic structure which is there in pyridine sulfate. Apart from that, we will be having ethoxy group, one hydroxy group, and quinupridine nucleus. Okay, this is called as quinupridine nucleus. Okay, so this is the structure of your pyridine sulfate. Sulfate is nothing but HSO. Okay, it is in the form of salt. Mechanism of action is nothing but they will block the open state sodium channels. Okay, they belongs to as it belongs to the 1A class, it will block the open state sodium channel, thereby prevent the sodium entry and prolong the recovery period of the cardiac cycle. Clear? So uses will be, it can be used as both. It can be used as both as an arrhythmic agent and sometimes it can be used as alternative for malaria. Okay, because pyridine and quinine both are the isomers. Okay, quinine is nothing but it is related to the malaria, whereas pyridine is nothing but it is an antiarrhythmic drug. As both compounds will have the same structure, they will have some similar property, so that this can also be used for alternative for malarial treatment. Okay, and apart from this, if you see arrhythmia, it can be used for treating supraventricular tachycardias and ventricular tachycardias. Okay, supraventricular and ventricular tachycardias, and it can also be used to abolish the re-entry mechanism. Okay, re-entry mechanism. Re-entry is nothing but, even though if we block the channels, again sometimes what will happen, the channels will get activated and the ions will enter again. That is called as re-entry. So in such cases also we will be using the pyridine sulfate. Here, and second compound you are having, that is nothing but your procainamide. Amide is nothing but C double bond O NH. So if you see the structure of procainamide, you will be having one aromatic amine group which is attached to the your amide functional. So this is the structure for your procainamide. Okay. So if you see the mechanism of action and uses for this drug also, the same uses and mechanism of action will be applicable as that of your pyridine. Okay. And third most important drug where you have to see the SAR and synthesis also. That is nothing but what is the drug? Diisopyramide. Third drug is diisopyramide. Okay, as usual. Okay, as usual, we can take the structure from the name itself. Okay, we can take the structure from the name itself. What is diiso? Two what groups? Diiso is nothing but iso is nothing but isopropyl group. Okay, there is a difference between propyl and isopropyl. Propyl is nothing but linear chain of 3 carbons. Isopropyl is nothing but at second position you will be having branch. Okay, that is called as isopropyl group. Diisopropyl is nothing but the presence of 2 isopropyl groups. PYR, pyridine. Okay, PYR is nothing but one pyridyl ring, and amide. Amide is nothing but C double bond of NH2. Okay, so the structure will appear like this. Okay. This is the structure for your diisopyramide. Amide is nothing but amide. Okay, pyridine is second position you are having, and diisopropyl is nothing but 2 isopropyl groups. Okay, this is one isopropyl and this is one isopropyl which is attached to your nitrogen. Clear? So this is the structural features of your diisopyramide. This is nothing but phenylene. Pyridine, isopropyl groups, and this is nothing but your amide. Okay, and this is called as glutamate. Glutamate. Then, so if you want to study about the structure activity relationship, you already know diisopyramide from name itself we can derive the structure, and you are having one pyridine ring, one phenyl ring which is attached with a common carbon, followed by the presence of amide group and glutamate which is linked to your diisopropyl group. Clear? Now if you see, first you take phenyl ring. Okay, so phenyl is essential for activity. If you remove the phenyl ring or if you substitute with any other groups, okay, the activity is going to decrease. Okay, phenyl is essential. Next, same will be applicable for pyridine also. Okay, pyridine at the second position is optimum for activity. Okay, you cannot alter the pyridine moiety. If you replace with the other heterocyclic groups, the activity is going to decrease. Next, you are having amide group. Okay, this is nothing but your amide group. So amide group is essential for activity. If we replace with either secondary amide, okay, this is the primary amide because NH2. If you replace with secondary amide, the activity is going to decrease. And if you incorporate a cyano group, cyano is nothing but nitrile, CN, C triple bond N. So if nitro group, cyano group, if you introduce, then the activity of compound will be changed from arrhythmic to anti-convergent activity. Clear? Clear everyone? So if you replace the amide with either secondary amide, the activity is going to decrease. Okay? And if you replace the amide with nitrile group, okay, nitrile is nothing but C triple bond N, we can call as cyano or nitrile. Then the activity of the compound, instead of showing arrhythmic activity, it will be shifted to anti-epileptic activity, anti-convergent activity you get. Okay, so somewhat similar type of structure you can see phenytoin also. That's the reason why phenytoin will act both as antiarrhythmic and your anti-epileptic drug. Clear? So with respect to now your diisopropyl group. Okay, these diisopropyl groups are essential for activity. We can replace with lipophilic moieties. Okay, we can replace with lipophilic moieties, other lipophilic moieties. The activity will be there, but when compared to this compound, the activity will be decreased. Okay, the activity will be retained, but it will be less potent when compared to the actual drug. Okay, so these are the structure activity relationship with respect to diisopyramide. Clear everyone? Just we'll recall once. Phenyl ring is essential for activity. If you remove the phenyl ring or if you substitute any other group, the activity is going to decrease. Okay. And second one, pyridine. Pyridine is important or optimum at the second position. And if you replace with any other heterocyclic compound, the activity is going to reduce. Okay. Third, if you see the isopropyl group, the isopropyl group is essential. We can replace with the lipophilic moieties. The activity will be there, but less when compared to the original drug. Clear? And at the second position, the amide is essential for activity. If primary amide is replaced with the secondary amide, or if it is, the activity will be decreased. If it is replaced with cyano or nitro group, then the activity will be converted into anti-epileptic activity. Clear? So this is the SAR for your diisopyramide. Clear? Now you have to see the synthesis. So first thing here, this compound you have to synthesize. Okay, if you see the structure, do some retrosynthetic analysis, that is nothing but back engineering. Okay, first you have to synthesize this one. After that, this moiety will be attached. Okay, this moiety will be attached at a time, and next you will be having amide. Finally, you will convert the amide group here. Clear? First, you have to take your CH2Cl, because we need amide here. Amide will be getting from acid. Acid will be getting from cyano group. Okay. If you do cyanohydrolysis, then you will get the acid. Okay. That's why we have to put the cyanide. And this carbon we need. That's why we have to put the CH2. Okay. What is this one is called as? We can call it as phenyl acetonitrile. Okay. Or we can also call it as, for telling something, benzyl cyanide. Benzyl is nothing but benzene is attached to CH2. If it is C double bond O, then it is called as benzoyl. Okay, that is the difference between benzyl and benzoyl. So benzyl cyanide or phenyl acetonitrile we can take and have to treat with the 2-bromopyridine. 2-bromopyridine, because we need pyridine. Okay. In the presence of strong base, that is nothing but sodamide, NaNH2. Sodamide, NaNH2. What it will do? The hydrogen, the sodamide strong base will remove one hydrogen from here. Okay. And bromine from here will be in the form of minus H. Okay. So one hydrogen bond, only one hydrogen will be there. The structure will be like this. Here you will be having Cl. This is the structure you are going to get. Clear? Then you have to treat with this group. Okay? Butanamide. Whatever butanamide we are referring, this is nothing but you have to take as, so most of the synthesis you will be taking as chloro-derivative, because HCl is easy to remove. Clear? So total group you take Cl, CH2, and you are having N, isopropyl. Clear? So what will happen? Again you use sodamide, NaNH2. As it is a strong base, it will remove hydrogen. Okay? It will remove hydrogen. HCl will be going, and this whatever this carbon will attack on this one. Clear? So you will get now CH2 and isopropyl. And here you are having cyanide. So this is the compound. We have got. Clear everyone? You are having any doubt? So now up to here you have got. What is the difference now? Here cyanide you are having, here amide you are having. Generally, if you do hydrolysis for cyanide, you will get the acid. Okay? COOH. But if you do partial hydrolysis, you will get the CONH. Partial hydrolysis. Okay? So you do partial hydrolysis in the presence of H2SO4. Partial hydrolysis, you will get the compound, our desired compound. That is nothing but your diisopyramide. So this is the compound, final compound that you are getting, that is nothing but diisopyramide. Okay. So if you want phosphate salt, then you have to treat with the phosphoric acid. Okay, H3PO3. Okay, to treat with H3PO3, you will get the phosphate salt. Clear everyone? Synthesis. Mechanism of action, you already know. It will block the sodium channel open state. Okay, for 1 to 10 seconds.